but this is twofold here, right? I want to introduce something that I think is important enough to mention, and then kind of explain how I and like other folks I've seen are solving the problem, and then kind of put it back to the community of is somebody else got a way to do this that I haven't, and go from there. But let me share my screen and we'll ask questions. Window, here we go. So I'll start with this, and when you guys can see my screen, let me know. Yeah, cool. You should see kind of a spooky looking paper slash website from some smart folks at Carnegie Mellon, right? Ultimately, like what's happening here is they've taken the shared universal like dependencies of most language models, meaning like Common Crawl, Transformers architecture, et cetera, and found ways to, you know, say, all right, I can't steal someone's identity, but if I add a control string, which you'll note looks remarkably like parameterized URL, right? It's easy to do. If you hadn't seen this, I'm sorry for the bummer. This is not just prompt injection. This is actual like attack strings. And to make it worse before it gets better, right? Here is like a link that I'll pop in the chat to the actual like class for how you parameterize and build these. I'll share it in a second. But ultimately, it is trivial now, is what I'm saying, to generate attack strings that you can reuse. And because there is an n number of these things, it's not like you can just code business rules to solve for like a given prefix. Right now it's downloading. I'm rerunning this Colab notebook again. So here in a second, I should be able to pull some more for you. But part of why I've got a Colab notebook is because I wanted it to be easy for people to run these experiments themselves, right? Get a sense for what these attack strings look like. Because what I'm hoping to do, right, other than having kind of a weird 80s themed website, right, where I'm trying to be loud, but in a funny way about a very real problem, namely how do you monitor like n-dimensional drift, like in a vector space, right? Especially when these things are universally vulnerable. What I've done and what I've found, right, is that using kind of default architectures of an abstracted runtime and through some pretty normal, data engineering of input preprocessing, enrichment monitoring and clustering, output post-processing and forecasting, right? We get to a place where, I've got a couple Lambda functions, I've got a DynamoDB instance, and another Lambda. Not that this is technology specific, right? But that with some very simple wrapping, we were able to have me sleep again at night, is the joke, right? That suddenly these things are easier to monitor, easier to not have to worry about because you know that what's going to the customer is something that you've vetted and validated. And I'll pause there because the next step for me is going to be, using these generated strings to try to train a model that's able to differentiate between a parameterized URL and an attack string. But that ultimately, if you guys have not already been thinking while you're using semantic kernel about how you integrate this into your application stack, how you sanitize your inputs, how you monitor your outputs, right? And then you're going to have a bad time. And not just because the runtime is vulnerable, but because you should be using conformal prediction instead of like Bayesian statistics, right? To forecast your outputs. And so I'll pause because the question is really one of the community. Have other people been worried about this? Am I alone? And then secondly, how are you guys solving for it? So thanks, Alex.
Go ahead, Doug.
I don't have a solution for this, but I saw this article when it came out, and my initial reaction was the pre-processing, just like detecting intent in that sort of skill. The garbage English that the examples all depended on seem like a really just two rules that I've considered putting into our product. One is, I'm sorry, that isn't language I understand just because it's garbage and I can detect it with a regex. And then if I'm doing a gather step, if my query against my embeddings returns nothing with high confidence, below a threshold, then I also bail to sort of generic, I'm sorry, I don't understand what you're talking about kind of output, and never send it to the LLM in the first place. You're also on mute, David.
Cool. Well, now we get to be there together. So thank you, Doug.
Yeah.
So I'm using conformal prediction just because I used to be like a Bayesian guy. And there was a pun that I used to have, but I don't care enough about the pun right now. we've done the same, not using regex, right? But we're basically appending like a prediction interval rather than a confidence interval, and that anything that deviates by like a set value from the expected like vector space where our outputs have traditionally been, right? It starts talking about underwriting instead of policy administration, then we shut that down, right? Because we both want to make sure the models generalize well, and because we want to make sure they're not being attacked. And that's where the stuff from like latentspace.tools, right, which is just my weird version of my own GitHub, explains like those 5-step processes, because we maybe it's only me and a couple other paranoid guys, right? But we took it a step further with output post-processing, right? And the weird Jimmy Neutron thing will also do like enrichment of your data, vectorization, and like identify new clusters or new values, so that you actually have like a real-time hook. You're not just kind of banking your money on your pre-processing, but you actually have like real-time monitoring of what's going on.
Sure. I mean, I think that having the model be able to deal with it is like far more robust than what I was talking about. But my thought was, in an application, I wouldn't actually have this output, but it would be like LOL is your cat on your keyboard, right? Because that's what.
Oh, I got you. Like additional to my like lambdas, you're saying like building it into your application, building the same principles into your application.
Yeah, right? Exactly. Just some basic detectors for garbage input and rejection of them, carte blanche. Seems like a perfectly fine response from a system if I get a wad of non-English characters followed by
so long as you don't
garbage,
right? URL, right? Yeah.
Well, like SQL injection attacks and other things. I don't know. Do you think, not to like derail the conversation, but it seems to me that people are going to be coming up with these novel scenarios for years as they come up with individual techniques for jailbreaking it, and so nipping it in the bud on the front end is maybe an easier generic approach in the meantime.
Agree on principle, except that there's not enough like determinism in how these things are generated that you can really do regex. And I love that, having used regex in our first deep learning thing, right? Along with an RNN that kind of highlighted the text we thought was important, right? Like 5 years ago. The issue is that because these things are templatable and like easy to generate specifically, it's easy to get past the regex, and that's why I'm interested in, like, just wish me luck, I guess is what I'm saying. And I want to train a model that differentiates, because then you can have a confidence that this is actually a link to YouTube that I wanted to transcribe versus, something that's trying to harm the system. But I'm glad that I'm not the only person thinking about this, and glad that you're already kind of building this logic into your app. So thanks, dude.
Yeah, that's
thank you for working on it. That's really cool.
How about from the rest of the people on the call? Anyone else have any tips and tricks for securing their AI apps? Cool. No, it's a good discussion. I was just recently watching a talk on kind of like security co-pilots and what people are thinking about. And one example that was shared was, it's not even LLM specific, but it just gave a product example of like Twitter. People have found creative ways to bypass their spam filter, and it's literally by, people want to like upvote a post or like massively retweet something, they will just add like some special characters just at the end of it, and by doing so, like, it could literally still be the same text, but just with the addition of these special characters at the end, it's able to bypass those spam filters. So
yeah, like the model detects that idiosyncrasy as if it's like novel stuff that it should wait. Yeah, that's, love regex, but it's going to get weird before it gets like normal again. So
David, is the end result going to look like a classification algorithm, like a spam filter? Or is it baked into the model? Okay, yeah.
Based, at least for now, the only way I can think of on like the things that you can parameterize, right? And forgive me that I didn't put that link directly to like the template, right? But this is the actual class, right? That you can have a goal, a target, like a tokenizer. Like you can try to key in on specific idiosyncrasies. So I'm thinking like an ensemble of models that kind of looks at it and says, oh, I know what that is, right? So that's the goal. I just got to generate enough like strings and then generate enough like parameterized URLs that are representative of like the top 10 websites or whatever. But I'm gonna try to do like direct preference optimization too, so that like you build in like a reward function. So Doug, I'll hit you up as I get more on that, and then once I have something that works, I'll come back. Otherwise, I'll leave Alex alone until then. So.
Cool. I also want to double or thumbs up Doug's comment that as these models get better, you can also rely on them to do more of this type of classification work. And you could have a scenario where you have many models kind of all checking, validating, securing your AI.
Agree in principle. I've actually got like, I don't have it handy, like kind of a rank ordered list of how you deal with hallucinations, and the same is true. The reason I would suggest like an RNN rather than an RNN or like a naive classifier, right? Is that an RNN has like de facto attention, right? For lack of a better word, like it has like semantic awareness, but it is not like all predicated on transformers and common crawl, meaning that you can get your classification going without like introducing a log4j vulnerability, for lack of a better word, you know? So
Sure.
Thanks, dude. So.
No, that's good. That's good.